Hello everyone and welcome to our YouTube channel Quick Solvers. Here I want to simplify this expression here where we have the 6th root of 12 times the 4th root of 54 times the 3rd root of 2 times the 4th root of 6. This is a good question for you if preparing for GRE or GMAT, and the difficulty level of this question is medium to hard. So let's see how can we solve this. To solve this question, we need to take 3 steps. The first step says that we need to decompose each term, each number here, like 12 here or 54 here, or 2 times the 4th root of 6 here, to the same factors. For example, I can write 12 as 4 times 3, okay? And I can further decompose this to 2 times 2 times 3. Or I can say 12 equals 2 to the power of 2 times 3, okay? So I should try to do the same thing for each term here and here as well, trying to decompose that to factors like 2 and 3. Something similar for all the 3 terms here. So that's the first step. And the second step is trying to find, or it's actually raising the index here and here and here to the same number. And that's actually, in this case, it's finding the least common multiplier of 6, 4, and 12. I'm sorry, 6, 4, and 3, which is 12. So in the second step, we need to raise this 6 to 12, this 4 to 12, this 3 to 12. And if we do that, then we have 3 terms with the same index, and that means we can combine them, we can merge them easily. All right, and you will see how to do that. And the third step says if we have something like this, the mth root of a to the power of n, this is equal to the mth times x root of a to the power of n to the power of x. Okay, so if I write it in different color, maybe makes it more visible. Here we have m times x, and here we have x. So that means if we multiply the index by x, then we need to raise the whole expression here to the power of x. Okay, so by applying these 3 rules and these 3 steps, we can simplify this. So let's see how can we do that. Well, we start by 12. By step 1, actually, I can decompose 12 as let me write in different color. We can decompose 12 as 2 to the power of 2 times 3. We already saw that. I can do the same for 54 because I can write it as 2 times 27, okay? And 27 is actually 3 to the power of 3. So here, 54 equals 2 times 3 to the power of 3. And then we have 2 times 4th root of 6. I can't do much here except this, 2 times 4th root of 2 times 3. So here you see that I kind of decomposed each term to factors like 2 and 3. All right, so this is the first step. The second step is to raise each index here to 12, to the same number actually, because then I can merge them. So if I want to raise the index here from 6 to 12, I need to multiply this 6 by 2. I need to multiply this 4 by 3 to get 12. And I need to multiply this 3 by 4 to get 12. Okay, so let me write it here. Multiply it by 2, multiply this by 3, and multiply this by 4. Okay, and in the third step, we saw that if we do that, then I need to take this also to the power of 2. We need to take this 54 to the power of 3, and we need the whole term here to raise this to the power of 4. Then we can replace the indexes by 12. That means we can in the next step we can get this. We can replace 12 by 2 to the power of 2 times 3, 2 to the power of 2 times 3. And since the index here is 12, then the power here would be 2. I have to raise the whole term to the power of 2. Okay, so now this is actually equal to this. And for the second term, again, the index is 12. And instead of 54, I will write it as 2 times 3 to the power of 3. 2 times 3 to the power of 3. And since I have raised the index from 4 to 12, then I need to raise this 54 or its equivalent to the power of 3. That means I have power of 3 here. And for the last term, the index is 12, and we have 2 times 3, and the index is 4 to the power of 4. Okay? And now you see this 4 and this 4 cancel out each other, so I can directly write this. And this is 2 to the power of 4, okay? Maybe I skip that step. Maybe I can write it again. What has happened here? Well, it was like this. 2 times 4th root of 2 times 3, okay, to the power of 4, okay? So if I distribute this power of 4, then we have 2 to the power of 4 times this term, this expression here, to the power of 4. Okay, let me do that. Then I can remove this and write this as 2 to the power of 4 times then the 4th root of 2 times 3 to the power of 4. And now I can remove this. Well, this power of 4 and this power of 4 cancel out each other, and what is left is this. Okay. Well, since we have the same index here, here, and here, I can write it down like this. And I will take down this term and this term and this term all here. Then we have, at the same time, I can distribute this to the power of 2 to the terms. Well, we know when we have a to the power of m times b to the power of n to the power of w, this equals a to the power of m times w times b to the power of n times w, okay? Then we can do that here directly. So here we have 2 to the power of 2 times 2, which is 4, times 3 to the power of 2, times the second term, we have 2 to the power of 3, times 3 to the power of 9. And for this term, we have 2 to the power of 4, times 2, which is 2 to the power of 5 totally, times 3, okay? 1, okay? And this equals, well, you see here, this one and this one and this one have the same basis, so we can sum up the powers. 4, 3, and 5 give us 12, okay? So we have 2 to the power of 12 because this one, and this one have the same basis. Then we sum up the exponents. And that's the same here, 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 and here. They have the same basis, so we sum up the exponents, and that will give us 3 to the power of 12. So we have 2 times, and of course the index is 12. 2 to the power of 12 times 3 to the power of 12. I can write this as 2 times 3 to the power of 12, and the index is 12. And that's because the bases are different, but the exponents are the same. So I can keep one of the exponents and then multiply the bases. And 2 times 3 is 6, so we can directly write 6 to the power of 12 here. 6 to the power of 12. And you see that this 12 and this 12 cancel out each other, and what is left is 6. And this is telling me that this is the right answer.